All right, 11.4 is looking at logarithms. And in logarithms, the things that we need to know is we've been working with y equals b to the x power. That was what we did last time in here for our sections. And the reason and what we had happening with that was that if we put, of course, this on our calculator, we found that our graphs from this ended up doing one of these numbers and going up in those kinds of directions when we had our stuff in there. We also had worked with reversing our exponential values. That's where we put in x where y was at and y where x was at, and we ended up going back through and reversing our values, because if we found that they were in one-to-one correspondence, we could do that. Well, with these guys, it's hard to take those and reverse them into their inverses, and so what was, of course, developed is that when we do that, we end up getting what's called a logarithm out of that graph. The thing you have to be aware is that this base b needs to be greater than 1 if we're taking a look at some of these things and seeing what does end up taking place with that. So be aware of that part in there. If we looked at a logarithm as a reverse of this whole thing, y equals bx, the logarithm ends up being, let me get my piece in here in relationship to that, is that we end up taking these pieces that we happen to have in here, and they all have a genuine meaning that goes along with that. And in our log, as we work through those, my right page here, is that if we start putting some numbers in here, let's say we have 2 to the 5th power is equal to 32. We all agree to that? That 2 to the 5th power, if you put on your calculator, would be equal to 32. So in our log, if we do a reverse of this thing, we're going to have a log. We are going to end up taking what our base happens to be and putting it down here as the little subscript that goes with our log. And then we're going to take what's equal to and put that next to it. And this whole thing, if we calculated it out, would come out to be equal to 5. And so what did I do to get this log piece to come out? I have a base, I have an exponent, I have what it's equal to. So when I create a log out of this whole thing, it's log, the base goes down here, the answer goes up here, and it's all going to be equal to the exponent. So we end up having our values in there and reversing and changing these things around from one to the other. So if I had 2 to the negative first is equal to 1/2, what would my log look like? Well, my log in this case would be log, base is 2, its answer equals 1/2, and that's equal to a -1. And so I can reverse them to come up with what my solutions happen to be. Does that make sense? Okay. So you're just kind of taking things and reversing them around. So if I had b to the 4th power is equal to 5, my log on this would be log b 5 is equal to 4. So you're reversing stuff and coming up with what your values happen to be out of that and what ends up taking place with those. Need to do more of those? Of switching them? We will get to more at the end of going through of all of our lesson stuff that we happen to have here, because we got to reverse them around. There are some basic properties of logarithms. And those basic properties, number 1, is that if b to the 0 is equal to 1, we all agree? Anything to a 0 power is equal to 1. The log of this thing is log b1 is equal to 0. So if you happen to get something in that situation where you have a 1 as your answer, we automatically know, regardless of whatever this base happens to be in there, that's always going to end up being equal to 1 or to 0. So an example might be 7 to the 0 power is equal to 1, so its log will be 7, 1 is equal to 0. So if you see that combination where you get a 1 in this position, it's automatically going to be known to be 0 for that one because of reversing those. Number 2, the second one, is b to the first power is of course going to be equal to b. And that happens because log b to the b is equal to 1. And that means when these two pieces match each other, your answer is always going to be 1. So if I had 8 to the first power is going to equal to 8. So the log 8 is equal to 1. So again, notice these 8s are in matching pattern there, and so I know that I have 1. So if you can remember those, that's going to end up helping you out. This next one is kind of a different kind of looking one because it's x equals b log bx. Now it's weird because it has a log kind of within a log when we kind of get this thing broken apart, because if I follow my rules say the log of the base to the answer is equal to log bx. And what do you notice? Each side is identical to each other, and so you end up having that combination where they happen to come out to be the same. This also goes into the fact, if you just look at the one, log b bx is equal to x, meaning that if I have a bases are the same, or this base here along with its answer are the same, the exponent on that is what my answer is going to be. So the x would come out to be what I would have for that one. And so that's kind of giving you the ground floor of all of these and what we have happening with those. So let's put one up here that you got an idea of what this whole thing is talking about, because I think this one's probably the more confusing of the ones that are there. So let's see here. We've got, so if, in other words, if I had 15 log 15 20, what would that, oops, get it on the paper, that would help me out with, what would this mean? Well, notice this and this are both 15s, so my answer to this whole thing is simply going to be 20, if I can recognize that. And they're always in the same pattern. It's not like they give you different pieces in here and different parts that are in relationship to that. So they'll all match each other with what you have for those. Another example of that one might be log 3 9. If I have this one, 9 is actually 3 squared, because that's what it happens to end up equaling. And if I can get it in this format where these two match each other, then I can simply get my answer of 2. And so they end up matching and getting that combination in there. So that you have some stuff that does come together and end up with what your values are. So you want to watch those and see what happens. Another one might be log 10 with 0.001 after it. This piece that's in here is a base 10 number, meaning that my base in my logarithm is 10. This whole thing up here, if I put it in terms of a base 10, what would it be? What would be its exponent on that? Because it's a decimal, I know that it's going to be a negative number. And if I look at my spaces that's moved over as 1, 2, 3, kind of using what I would with scientific notation, I know I'd have a negative 3 there. And when these two bases match each other, my answer comes out to be a negative 3 is what that log happens to be equal to, because again, it's got a negative 3 that's connected with it. So there's some breaking down of these things. Pay attention to this piece that's at the tail end. Pay attention to this base. because if you can break those apart and get them into this format, then you can end up finding your answers in there. Because usually the relationship is here between this, the original base of your exponential form, and the number that you happen to have up here. They kind of coincide with each other. So you want to look for some patterns that happen to fit in there with those. If you happen to have, though, this one, for instance, log 7, -3. If this answer is a negative number, can I come up with a negative number when I take things? And in this case, if I reverse it, it would be 7 to the x power equals a -3. Is there any possible way of getting a -3? Raising 7 to some power and get a -3? What do you guys think out there? No, there's no possible way. So this is undefined. So in some cases, actually most cases, if you've got a negative value that happens to fit in this position, you know that it's going to end up becoming undefined, because there is absolutely no way in which I can see that thing and what takes place with it. So it does end up becoming an undefined situation in there for that. So be careful and watch out for those undefined pieces. But if you happen to have 7, log 7, 21, what would be my answer? Once again, these two match, so my answer would be 21. So there's patterns and stuff that you have to look for within those to see what does end up taking place and seeing what your answer does come out to be. If you have one that looks like this, log 8x equals 2/3, what am I going to end up with? So if I take this thing, somebody's phone is going off. If I have this, what's the pattern going to be if I turn it back into exponential form? Well, it's going to be 8. This answer to the other side of my log is my exponent that happens to be on there. So I end up with 8 to the 2/3 equals x. So now what I have is it's kind of going back and looking like what we had in some of the previous sections. So it's 8 to the 1/3 raised to the 2nd power, if you want an exact answer to it. So this means the cube root of 8. So what's the cube root of 8? So a little bit of chapter 9 coming back in here. Cube root of 8 is 2. 2 squared is 4. But if I also grab my handy dandy calculator and I put my calculator in here, clear out what I've got in there, and I take 8 caret, put my parentheses 2 divided by 3, parenthesis, hit enter, I still get the exact same answer of 4. Okay? So when you reverse these, you can end up going back and using your calculator to help you out with them instead of going back and reversing it. But we can do it by hand and end up reversing it. Pardon? No, it's got, my calculator had a little mark in there. It's a regular 4. There was a little, just a little bit of something there. Yeah, thanks for asking though. No, it's a positive 4 is what you end up with. So you can use your calculator to help you with some of these as well. And so that might be a good point to take a look at. Now it does not ask you to do graphing with these, although within the instruct part it does end up showing you a graph of what does end up taking place with these. And your exponential graph will come up at the top. So if that was y equals 2 to the x power, I would have that type of a format with that. If I did its inverse, which is to turn it into logarithmic form, it's going to be log little 2, and my answer that I have with this one is, I don't know. And so it's reverse, because if I'm going to reverse this, I have to reverse this piece in order to get it to log format. So remember, whatever was your y became your x, and whatever was your x became your y, when we were talking about that before. So if I have log 2, my answer was x raised to the y power, I end up with that format. Now the thing about these, when you get its inverse, the inverse of this graph is doing something on that order. And what they have in between here is a line, and that's called an asymptote. And again, don't worry about the full-fledged definitions with these, because it's never going to ask you for that. But they just wanted to show you what these pieces would end up becoming if you had worked them out to get your reverse of your graph. So that's the kind of thing that's going to happen. And again, it's a mirror image, because you've got a point over here, which is also a point over there if you reverse your values. And so you just get this pattern and get this shaping that goes in there to come up with those. And then if we looked at domains, again, they bring back domains. The domains of this whole graph end up being, of course, everything that's in there, correct? We can pick out any x value that we want to pick. So our domains that we happen to have end up being, of course, all real numbers. But our ranges, just like before, are limited, because I can't always pick every kind of y that I'd want to pick for all of these, because my y's, if I look at my range, which is my y-axis, I start to be limited because I can never touch 0. Okay, so x needs to be greater than 0 in my range if I'm looking at a regular one, and it just depends on what type of stuff you have going in there. And again, your ranges, they're not asking you a whole lot with domains and ranges in your homework assignments either. But again, it's just sticking them in there so that you have an idea of where those happen to be with that. Okay, what do you guys think so far? So far we're on track? Alrighty. So then to get into some of the problems that they end up giving you, they're basically the same as we just got done talking about, but we'll go through some more of them and see if we can come up with answers. These are all going to be log problems. And what does this one tell me? Well, this one tells me I have 27 to the negative 2/3 power is equal to x. And so what would my answer be? So if I worked it out by hand, it would be 27 to the 1/3 power raised to the negative second is equal to x. 1/3, or the cube root of 27. You guys remember that one? 3. And 3 to the negative second power is what? What is 3 to the negative second power? The negative 2 means it's got to go to the bottom. So I end up with 3 squared becomes positive. So really my answer is 1/9. So you get 1/9. Now, if you use your calculator on this one, and you go through and you put your value in here, 27 caret parenthesis negative 2 divided by 3 parenthesis. If that were my piece that I plugged in here and I hit enter, it's going to give me a decimal answer, and it's not going to look for a decimal answer in Hawks. But if you go to your math button, hit frac, put it in after it, it will give you your correct answer. So if a decimal ever comes out, make sure that you change it back and end up with your 1/9 in there for your solution to that one. And so you get your 1/9 value out of that. Here's another one. How about this one? Log 9 x to the negative second equals x to the negative second. What's this one going to be? If I reverse it, it's 9. Negative 2 is equal to x. And because I've reversed it in there, what comes out of this piece? So Once again, 1 over 9 squared. 9 squared is 81, and so my answer comes out to be 1/81st, would be what I'd put into my answer for that one. So you can come up with some different values with these. Here's another one. How about this one? Log 16, 4 is equal to x. Now, when you take a look at this one, I have 16 to the x power is equal to 4. The other part that gets added into this section is that if I can get my bases to look the same, then my exponents will be equal to each other. If you look at 16, what do we know about 16 in relationship to 4? What was that again? Yeah, perfect square of what? Yeah, perfect square of 4. So 16 is equal to 4 squared times x, and 4 is, of course, to the first power up here. And so what ends up taking place is 2 times x gives me 4 to the 2x is equal to 4 to the first. And being that my bases match each other, notice they're both 4s, my rule states that if the bases match, the exponents are equal to each other. So 2x is equal to 1, and then what I can do is solve it by dividing both sides by 2 and finding out that x is really equal to 1/2. And does it work? 16 to the 1/2 power, so if I want to check it on my calculator, 16 caret parenthesis 1 divided by 2 parenthesis, and notice I ended up getting back to 4. And so you can check them that way if you want to know whether you got your correct answer out of them or not. So it's this reversing of the logs and putting it back into the correct format. How about this one? Log x 64 is equal to 3. So if I take it and reverse it, I have x to the third power is equal to 64. So what would give me that answer? What must x have to be to give me 64? Well, if I use my rules from chapter 9, I can take the cube root of each side. And what's the cube root of 64? So if I go math, what was it? 4. Yeah, you guys all got that down. So if I go to 4, or go to the cube root of 64, I get 4. So x must equal 4. And sure enough, 4 cubed does equal 64. So I found my answer to this one. So that x that's in there, I can end up finding it by, of course, reversing things and moving it back into what I had before. How about this one? Log 3, 3, log, and this one's kind of a complicated one. 464 equals x. The reason this one's a complicated one is because it has 2 parts to it. Because I have 3 to the x power is equal to 3 log 464. Everybody okay with that part? Again, here's my base. There's my exponent. This is what it's all equal to. Now if we take another look at this thing, our bases are the same, and they kind of snuck this one in on you. Bases are the same, so that means my exponents equal each other. So if I reverse this, I have 4 to the x power is equal to 64. So what must x be? We just finished it. So x must be 3. You might want to make sure you note that one somewhere because it pops up every once in a while in your Hawks exercises. So what we did was, because it was equal to x, I took my base to the exponent equaled this whole thing. Then my bases matched each other. So then I could take my exponents and set them equal to each other. So when I set my exponents equal to each other, Then I end up with 4 to the x power is equal to 64. And because we know that the cube root of 64 happens to be 4, I know I can get x is equal to 3. And so I can come up with what my answer would have ended up being in that one. So it's kind of a long one. It's got lots of different pieces in there to that one. How about this one? Log 7. 7 to the negative third is equal to 8. That's one of my properties that I had. So my property says if this and this match, my answer is negative 3. And that's all I have to do with it. Okay? Not much work with that one. It's just if I remember that. Now, can we work it out? Sure. If you don't remember that, remember it's 7 to the x power is equal to 7 to the negative third. Bases match. So my exponents get set equal to each other, and I get that for an answer. Okay? Yes or no? So I can still use my rule that says reverse this and get it to come back to what I happen to have there with those. And so it's a combination one. Let's do another one of those long ones, because I got one more in here. Log 6. 6 log 4, 16 is equal to x. So if we work this guy out, base to exponent is equal to what it's set up here to. Bases match. Exponents become equal to each other. Reverse it. 4 to the x power is equal to 16. And so my answer is? What would be my answer? 2. Mm-hmm. Yep, x equals 2. I think these are a little easier than some things we were doing. It's just remembering that you gotta shift it back around to end up with what your possible answer could come up to be. How about this one? Log 36, 6 is equal to x. If I reverse it, I get 36 to the x power is all equal to 6. Then what has to happen? Yeah, get my base is the same. 36 is really 6 squared times x. So really I have 6 to the 2x is equal to 6 to the first power. So then 2x is equal to 6. Or wait, 2x is equal to 1. Get my 1 in there. Divide by 2. And I find x is equal to 1/2. So I have a half in connection with that. So that half comes out there as my piece of what I have. Okay?
If you have TI-84, you can just put log 36 and 6.
You can, huh? Yeah? And it works out?
Yep.
Perfect. That comment was, let's see. Mine won't do it because it's an 83, huh? Oh, that's a newbie for 84. So there you go. The comment was, if you have an 84, you can do log 36/6 and get your answer, which is a half. Go to math.
And it's called log base.
Oh, well. Yeah, because I don't have it. Oh, under math, here's a fancy pink one. Math, go to log base. Oops, you were on log base. And this is again on TI-84s. It's not on our other ones. So I hit enter, and I put 36. and I go over in my other box and put 6, hit enter, and I get my answer of 0.5. So handy dandy for those 84 calculators. Now, that does not mean go out and grab and go buy a new one, you know, but it's kind of handy. Have that one in there. Pardon?
Now we have like 2 weeks ago.
Yeah.
I'm not gonna go out and buy it.
Yeah. Go out and buy a real fancy fandangled calculator.
What you just did, can we do it on these ones or no?
You can't. I don't think it's in there. I really
I tried
don't.
looking for it and it wasn't in there.
Yeah, it's not. I don't think they put them into 83s. So all of us 83 users do it by hand. But really the math's not that bad by hand if you know what your bases happen to come out to be. And these will always, 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 always work into some base. Okay? You may have to try some square roots and cube roots and so forth to get that back to that same base, but they all do. They all work back to that same identical base that you happen to have in there. How about this one? Log x 49 equals 2. Can't use this one on your handy dandy fancy calculator at all. So x squared equals 49. What would be my base? What times itself gives you 49? And we all know it's 7, right? So x equals 7 for that one. And so you can reverse it and come up with solid values on those. How about this one? Log. This one you can use your handy dandy calculator on. Log 8 2 equals x. What's that one going to be? So 8 to the x power equals 2. So what? 2 times itself, how many times will give me 8? 4? No, 2 times 2 is 4. Times 2 is 8, so it should be a 3. Yep. So it should be 2 to the 3 times x equals 2 to the first power, or 3x equals 1. Divide by 3, find x is equal to 1/3. So you get 1/3 out of that. And how about this one? Log 555 equals x. Log 555 equals x. What happens to that one? It's 5. Again, if you remember, your bases match each other, right? These two match, so your answer is simply that value up there. If you don't remember that, then it's 5 to the x equals 5 to the 5th. Bases are the same, so x is equal to 5. So you know what you got with that one. Okay? So your answer would end up being 5, of course, with that one. All right. More of these? Are you okay? What do you think? Okay. So if you're good with that, then that ends up being, of course, that section. 11.5. In 11.5, there are 3 properties that are associated. Again, there were 3 rules in the last one, now we got 3 properties. And the first one is the product rule of logarithms. And the product rule of logarithms says that if I have log x a b, meaning that I have 2 separate pieces that are being multiplied together that are giving me this log, the product rule says that what this is equal to is the log of xa plus the log of xb, meaning that whenever I have a multiplication, I have an addition situation taking place. Okay, so there's an addition part that's happening within this. So an example might be log 2 to x, which would be equal to log 2 plus log 2x for what that would end up becoming, because I would stretch it out and end up with two pieces of stuff taking place there. This one could be broken down even further, because the rules from 11.4 said that if this and this match, what was it equal to? 1. So this would actually be 1 plus log 2x, and you would end up breaking it one step farther to come up with what your solution would happen to be for that one. And so you can break them apart and do more stuff with those. And we'll do more practice with this stuff as we get into the practice part that we have. But I wanted to get all the rules or the laws and stuff that are out here. Then there's the quotient rule. And the quotient rule of logarithms it says if I have log x or y over z, for instance, a quotient, meaning that I have a division taking place in this location, ends up becoming log x, y, but it's a subtraction instead of an addition that I have, because this bottom part is going to be a subtracted piece in there. So you've got a subtraction taking place. So therefore, if I had log 2x over 3y, well, I don't want to put the 2 in there because then I have to break it apart even more. Just x and y we'll use. That would of course give me log 2x minus log 2y, because I'd have those two pieces broken apart, and I'd have to come up with that part in there. So if it's a multiplication, it's an addition. If it's a division, it's a subtraction with what you happen to have. They go and they put these two things together. So I might have something like log 3xy over z. And if there's a combination, then I would have log 3x. Because of the multiplication taking place right here between these two, I would have a plus log 3y. Each individual thing needs its own separate log when you break it apart. And then finally, because z is dividing it, I would have log 3z. And you'd end up subtracting those from each other. When you go to put these into your Hawks answers, you need to use the log key that's in your keypad, because that log key in your keypad will set this up for you, so that then you can put your 3 in and then you can put your x in with those. But you need to use your log keys in, or the log key that's in your keypad, to put those into your area within Hawks, and so you can have those with that type of situation that you have. And then the final rule is the power rule. And in the power rule, it is log 3x to the third power. If you have this situation, this 3, which is the power that's on x, comes down and goes in front of your log to get it to be broken apart in that manner. So the 3 comes out at the very beginning of what you happen to have. Now, if you had combinations of these that ended up matching, and you have another one that's next to it, you can treat this as if it were the x or the variable portion, and you could combine those together. As long as your base is the same and your letters are the same, you could end up combining them at that point. So if you take all of these rules and end up, well, let's do another one right here. Log 3x to the 7th, that would just be 7 log 3x, because the 7 comes out in front of that whole thing. Then if we stick them all together, can I turn it? Yep, okay. If I stick all of them together, and all together might look like log 10 x to the 3rd, y to the 4th, all over z to the 2nd. And if I have this one, I've got all of my three rules in here because these all have exponents that are on the bases. And we have multiplication happening, we have division happening. So in this case, the complete answer is 3 log 10x plus 4 log 10y minus log, whoops, I need my 2 in front of there, 2 log 10z. And so it breaks it apart and puts them all out into separate pieces and separate parts that you happen to have within that. Within the instruction part that is in Hawks, they go back through, and it's only in the instruction. I did not find any of these things popping up in my certifies that I happen to have, but they go through and they give you, just so you have an idea that this is what they end up putting in your instruct. They tell you what something is. This value of log 10 to, it's equivalent to, if you ended up putting it on your calculator using your fancy dandy, handy dandy calculators, it's equal to this amount. And then they give you log 10(3), and log 10(3) is 0.4731, and log 10(5) is equal to 0.6910. And then what they go through and do is give you something like log 10(6). And if they give you log 10(6), well, 6 is 6, but I could break 6 apart into log 10 2 times 3. You see how we break 6 apart? 2 times 3. And that would end up giving me log 10 2 plus log 10 3. And then what they substituted in is what the value of this would be plus what the value of that would be. So the value of log 10 2 is 0.3010 plus the value of log 10 3, which is 0.4731. And you add those two pieces together and you come up with your answer that you'd happen to have. So 1 and 0 is 1, 3 and 1 is 4, 7 and 0 is 7, and 3 and 4 is 7. So my true full-fledged answer would be that. Now, again, they went through and did division ones like that too. And so they may have had something like log 10 2 over 5. And if we have log 10 2 over 5, that is log 10 2 minus log 10 5. And they substituted in what each was equal to, 0.3010 minus log 10, which is 0.6910, and they came up with a solution to that one as well. And so, and what its solution happens to be is 0.3010 minus 0.6910. And we end up with a negative 0.39 would be our solution to that one. And so that's kind of the thing that they did in the beginning part there. If it's to a power, then of course you'd substitute what your piece is and multiply it by whatever that happened to have been. But again, they did this in the instruct part, but not in the homework part. So in the homework portion of this, they do end up giving you, let me go back here and find some of those examples that they do end up giving you. I don't want to start with that one. You want to do it, but start there. They give you something like this, log b, and they give you x, y, all over 432 for an answer, or 43z, I guess is what they had in there. And so how would I break that thing apart? Well, what I would have in the top part is a multiplication, so that means I have log bx plus log by. We okay with that part? minus what I have in the bottom, which is log B43 plus log BZ, because that's what's in the bottom, but that's got to be subtracted because that's my values. And then finally, you would distribute that subtraction sign and you would subtract the other part, and you would end up having your final answer. So that would be what my answer would be. And if I had to reverse it, whenever I see a subtraction, that tells me it's got to go to the denominator. And so if you reverse this whole thing, these two are on top. The log b is my common log. Then I would have x times y. Minus means 43 is in the bottom, minus z. Whoops. And that z would end up being in the bottom as well. So you'd reverse it and turn it back into what its value happened to be. Here's another one. Log 10 x to the third y to the third all over z. So what would I get out of that one if I turned it around into its values that I can add and work with? So because exponents, where do they have to go? In front. So I have 3 log 10x plus, because it's being multiplied, 3 log 10y. Because z is in the denominator, it means it's subtracted. And so that becomes my answer. All right? These aren't too awfully bad. It's just getting your stuff to break apart with them. So then let's go back to that one that I said I didn't want to do right off the bat. Well, we'll go back to this one. Log b x all over the square root of x to the 6th y to the 2nd. Well, if you look at this one, there's some simplification I can do. Because I can take the square root of x to the 6th, correct? What's the square root of x to the 6th? X to the 3rd. And the square root of y to the 2nd is y. And so that kind of breaks it down some for me. But if I still look inside of here, what do you notice also? This x and this x to the 3rd can cancel, leaving me with 1 on top. So what does this mean when I get around to writing it out in longhand? I could say that I have log b to the 1st power in the beginning, but log b to the 1st power is equal to, what did we find out before? 0 actually, because there's nothing really there. But if I go to the bottom, I need a subtraction. So I have 2 log x, not the b in there, and then I also have minus log by, because those ended up canceling out. If you left it in there, you would have log bx minus 3 log bx minus log by. But because these two match each other, notice this part matches, that means I can take 1 from 3, and if I subtract the 1 from the 3, that's where that negative 2 log bx comes in at, minus log by. So you can do it all out longhand and get everything out there that you possibly want, or you can end up canceling stuff out in the top part. I think they put about a couple of these usually in, at least that's what I had when I did my practice stuff and the certify stuff. Is a couple of them popped up in there. Not a whole lot, but some of them did. And how about this one? This one is broken apart for you, and you need to put it back together. Log 6x plus 4 plus log 6x plus 5. Now, because it's broken apart, I got to reverse my process. Well, my reverse process says I have log 6. Since it's an addition, it really means to multiply. So I have x plus 4 times x plus 5. And I don't think Cox will accept it that way. I know I always distributed this and multiplied it out, and it would go in that way. X times x is x squared. X times 5 is a 5x. Plus another 4x is 9x. 4 times 5 is 20. So this would be what I would put into Hawks. All right. Using my log key again, that's on my keypad, putting my 6 in, then going over to the other part and putting that part in as the raised value in there with that one. One that is, and again, I didn't run across many of these. But they're still in there. And so this one means that if I put this piece back together in the center, it's log 10x over y to the 5th power. And then I've got that 41 out in front. So it's log 10x over y to the 5th raised to the 1 over 41th power. But what does this mean? And this, I think, was the largest one that they had did with this variety in there that I'd run across. This 1 over 41, that is saying we have log 10, the 41st root of x over y to the 5th. Again, I'm not quite certain why they stick one in there like this, and I will not stick anything like that on your test. You won't run across one of these there. You will run across it in your other stuff. But I have to get rid of this denominator because I want to rationalize my denominator. So 41x and the 41th root of y to the 5th. So that means in order to get 41 right here, I need the 41th power of y to the 36th power, because 5 plus 36, that's 5 plus 36, 41. So really my full-fledged answer is log 10. 45th root of x, y to the 36th, all over y, because it removed that y out of the denominator altogether. And so 36, not 31, 36 up at the top. And that's what they're looking for your answer. So again, that one is a complicated one. It has some extra steps in there, but you want to watch out for it and see what it does with that problem. Let's take a look at another one that's similar to that. So you have at least a couple of them in your notes. This one is 1/5 parenthesis log b x plus 3 log b y. And this one's not as detailed because it's got a addition in the middle. And additions, of course, means it's going to come back as a what? If it's an addition, it's going to become a multiplication. So this one is log b x y to the 3rd, and all of this is raised to the 1/5. So really this is log b, the 5th root of x y to the 3rd, and that's all you can do to it, because I don't have to rationalize a denominator in that case. There's nothing I have to change or have to adapt or have to fix or have to do anything different with that one. And so that's what it happens to be when I work it out. So you get the idea of reversing them, going back the opposite way or going forward with those. And so they're just kind of changing from one to the other. How about this one? Log b, oops, x squared plus 8x plus 15 minus log b x plus 5. So if I have this one in place, what happens? Well, subtraction means I need to put it back together. So I have log b, x squared plus 8x plus 15 all over x plus 5. And in all of these cases where you run across this, that top part can be factored. But they give you a hint. What's the hint? Yeah, one's going to be x plus 5. Yep. But what's the other one? X plus 3. So they're always going to have something in there that you can cancel. So your denominator is going to cancel out. But again, this top part's going to factor, but it's going to have a factor in it of a binomial that is like what you have for your denominator. And so they'll cancel out within those. How about this one? Log?
Wait, so that's your answer?
Yep, my answer is log x plus log b x plus 3. Yep, that's my answer.
The exponent, x plus 3. Okay.
Yep. That's my answer. So that would be what I have with that one. Log 7, the square root of 7. What in the world is that going to break out to? Well, square root means, what does the square root mean? Square root means, what do you know from way back when? Square root means, somebody's got it out there. Come on. What's the square root? Square root's as a exponent. What was square root of a half b as an exponent? Or square root of 7? Well, it's a half actually. So this is log 7, 7 to the 1/2 power, or it's just simply 1/2 log 7, 7. And that's all it's asking you to do, because you have a power on there. You just need to bring it forth and put it at the beginning with that one. One more. Log 10 x plus 1 minus log 10 x squared plus 3x plus 2. So what's that one going to come out to be? So it's a subtraction. So it's really a what? It's a subtraction. It's really a division. Yep. So it's log 10 x plus 1 all over x squared plus 3x plus 2. But that factors to x plus 1 all over x plus 1 times x plus 2. And x plus 1's cancel. So my final answer is log 10, 1 over x plus 2. And that's what it would be if you put it in there for your answer with those. Yes, we good? Or are we not good? Need to do some more? Think you're okay? Alright. Okay. It leaves us 2 sections for next time. Then we're all done with new stuff. It's always a good feeling.